In the silence between stars, where the void stretches endlessly and galaxies drift like scattered embers, something stirs that is stranger than light, older than gravity, and more elusive than the particles that make up our very flesh. Imagine, if you can, that beneath every atom, beneath every quark, beneath every so-called fundamental particle lies not solidity, but vibration. Not points of matter, but tiny, invisible filaments, strings, that hum with frequencies so small, so swift, that the entire universe itself is their orchestra. It is a breathtaking proposition, one that dares to rewrite the very architecture of reality. A proposition known as string theory. And yet, in the very moment it inspires awe, it invites suspicion. Could it be true? Could the universe be nothing more than an infinite symphony of strings, each particle merely a note, each force merely a chord, and each law of physics a fragment of a grand cosmic melody? Or is this vision of vibrating strings just another illusion, a mirage conjured by the mathematics of desperate physicists reaching for a theory of everything? The hook of string theory lies not only in its elegance, but in its audacity. It claims to unify what Einstein and Bohr, Newton and Maxwell all wrestled with across centuries: the inescapable clash between the infinitely small and the infinitely vast. Quantum mechanics governs the jittering chaos of the subatomic world, while general relativity bends the fabric of space-time across galaxies. Two pillars of truth, yet they refuse to meet. At the heart of a black hole, at the very birth of the cosmos in the fireball of the Big Bang, these laws shatter. Physics itself breaks down, and into this fracture steps string theory, whispering, "What if you have been looking at the universe all wrong?" The opening image is not one of solidity. It is of threads, infinite in number, vibrating at unimaginable scales. The cosmos not as a machine, but as a tapestry. Particles are not the bricks of creation. They are the illusions of something deeper. A photon is not a particle of light. It is a note struck on a microscopic string. A quark, buried in the heart of a proton, is not indivisible. It, too, is vibration, plucked on an unseen strand. And these strings, in their vast combinations, may weave together every law, every force, every constant, every mystery. But if that is true, then why does the world appear so solid? Why do we not hear this universal symphony? Why, when we split the atom, when we smash particles together in our mighty accelerators, do we find particles instead of filaments? The unsettling answer is this: the strings are too small, a trillion times smaller than the nucleus of an atom. To see them would require an accelerator the size of a galaxy. And so, string theory teeters on the knife's edge between brilliance and fantasy. It is the most ambitious vision in the history of physics, and perhaps the most impossible to prove. Still, it has seduced some of the greatest minds alive. Edward Witten, the titan of modern theoretical physics, called it the most beautiful theory we don't know how to test. Brian Greene once described it as a theory of everything, or perhaps a theory of nothing. For decades it has promised a final unification, and for decades it has hovered on the horizon like a mirage, retreating whenever we draw near. And yet, whispers persist. In 1968, Gabriele Veneziano stumbled upon a strange mathematical formula while trying to describe the strong nuclear force. It looked nothing like what he expected. Instead, it carried the faint signature of oscillating strings. By accident, he had pulled at a loose thread of the cosmos, and the fabric began to unravel. From that moment, the story of string theory became one of breathtaking ambition and crushing doubt. In the 1980s, the first superstring revolution promised to remake physics, with equations suggesting that every force, even gravity, could be explained as the trembling of strings. The world of physics shook, and then came silence. decades of calculation, of refinement, of endless mathematics that grew stranger and more elegant, but always, always untested, always out of reach. It is here that our story begins. Not in triumph, not in certainty, but in the haunting twilight between discovery and myth. Because if string theory is true, then we do not live in a universe of 3 dimensions, but in a cosmos with 10 or perhaps 11, each one curled upon itself, invisible yet real. We would inhabit only the thin shadow of reality, blind to the vastness around us. And if string theory is wrong, if strings are illusions, if extra dimensions are ghosts, then perhaps the dream of a unified universe dies with it. Perhaps the universe is forever fractured, never to be reconciled, a mosaic of laws without a single design. This is the gamble of string theory. It is not merely a theory of physics. It is a wager on the very nature of reality, and it asks us a question we are scarcely prepared to face. What if the universe is not built from things, but from music? Yet there is a darker implication. Because strings do not merely unify forces, they spawn worlds. In the vast string landscape, there may exist 10 to the power of 500 possible universes, more universes than atoms in our own, each one with its own laws, its own physics, its own beginning and end. Ours is but one. The idea is intoxicating, terrifying, irresistible. If string theory is true, then the cosmos is a multiverse, an infinite branching forest of realities. And we are no longer the center of anything. We are a fleeting vibration in a boundless symphony. But if it is false, if the strings snap and vanish into mathematics, then we are left once again in silence, staring into a void with no unifying thread, no ultimate meaning. That is the opening image. A cosmos shimmering as though it were woven from threads, trembling with hidden music. And then, the silence of doubt. The hook is this: beneath the visible universe, perhaps there are strings vibrating, unseen, composing all that exists. But if these strings are real, then they may hold not just the key to matter and energy, but to time, to space, to existence itself, and the cliffhanger. If these strings are truly the foundation of reality, what secrets, what horrors, what wonders lie waiting in their song? The search for truth often begins with a single voice daring to speak against the silence. In the story of string theory, that voice is not one, but a chorus of dreamers, rebels, and visionaries. Among them, a theme begins to emerge, haunting, fragile, yet unrelenting. The theme is this: the universe is not built of particles at all, but of vibrations. And to confront this possibility is to confront the nature of reality itself. The universe, one theorist once said, is not a machine of particles but a symphony of strings. It is a sentiment at once lyrical and terrifying, because if particles are not fundamental, then the very bedrock upon which we built modern science, atoms, quarks, protons, electrons, may themselves be shadows, illusions cast by something deeper. The music of strings would be the true reality, and everything else, us, our world, our stars, mere echoes of its hidden harmonies. This is the theme of string theory. It is not simply an idea about physics. It is a radical reimagining of the cosmos. It says that all things are connected not through the collision of particles, but through the resonance of vibrations. That matter and energy, space and time, the forces of nature themselves, may all be different notes on the same cosmic instrument. Why does this matter? Because for over a century our best theories have stood divided. Einstein gave us relativity, the magnificent geometry of space and time. Quantum mechanics gave us probability, uncertainty, the flicker of existence itself. Each theory works flawlessly in its own domain. Relativity describes the vast, the arcs of galaxies, the crushing weight of black holes, the dance of space-time itself. Quantum mechanics rules the minuscule, the jitter of electrons, the collapse of wave functions, the chaotic symphony of subatomic life. But the two do not meet. They cannot be reconciled. Put them together at the edge of a black hole or at the dawn of the Big Bang, and their equations collapse into nonsense. Infinity swallows reason. Physics dies. And so the theme emerges, to find unity in division, to bring together what has been sundered, to listen for the music that lies beneath both quantum mechanics and relativity, the song that makes them one. This is not merely a scientific dream, it is a human dream. For as long as we have looked at the stars, we have sought harmony. The Pythagoreans imagined celestial spheres singing as they moved across the heavens. Medieval philosophers spoke of a chain of being binding all existence. Today, physicists dream of a single equation that explains all that ever was or will be. String theory dares to answer that longing. It whispers that beneath the chaos lies music, that reality itself is a symphony. And to question string theory is not merely to question a scientific model, but to question whether the universe has an underlying harmony at all. The theme is reinforced by the birth of the idea itself. In 1968, while grappling with the strong nuclear force, Gabriele Veneziano stumbled across a mathematical formula that seemed almost too elegant to be accidental. It described the scattering of particles in a way no one had expected, and its structure hinted at tiny oscillating strings. The strong force which binds quarks together seemed to hum with hidden vibrations. It was as if the universe had revealed by accident a fragment of its score, a few measures of its hidden music. And yet, string theory's theme was not instantly embraced. Physics is, after all, a world of skeptics, of cold calculation and empirical demand. Strings were beautiful, yes, but invisible. No experiment could reach their scale. No detector could touch their trembling. To embrace them was to embrace an idea that may forever resist proof. Still, the theme endured, growing in strength. In the 1970s and 80s, theorists began to see its implications. Strings could not only describe the strong nuclear force, they could describe gravity itself. For the first time, it seemed possible to bring Einstein and Bohr into the same song, to unify the broken world of physics into a single melody. But the theme has a darker counterpoint. If strings are real, then so too are extra dimensions, 10, 11, perhaps more. Dimensions beyond the three of space and one of time. Dimensions we cannot see, cannot touch, but which curl and fold invisibly around us. These hidden dimensions would be the resonant chambers in which the strings vibrate, shaping the universe we know. It is here that the theme becomes more than science. It becomes philosophy. Because if there are hidden dimensions, then what we see is not reality, but a shadow. We are blind to the greater whole. Like creatures living on the surface of a drum, feeling the vibrations but never glimpsing the hands that strike it, we live inside a universe whose true nature is forever obscured. And so the theme stated is both magnificent and unsettling. If string theory is right, we are not beings in a particle world. We are notes in a cosmic song. And to question string theory is to question the harmony of the universe itself. This idea, this theme, resonates far beyond physics. It touches art, philosophy, even theology. The idea that all things are connected by vibration is as old as human thought. From the chants of ancient mystics to the harmonics of Pythagoras, from the poetry of Emerson to the meditations of modern philosophers, the dream of harmony runs deep. String theory is its scientific heir, dressed in the mathematics of Calabi-Yau manifolds and M-theory, but carrying the same eternal longing that the universe is not chaos, but music. And yet every theme must face its test. Every melody must endure dissonance. String theory may be beautiful, but beauty is not proof. Critics demand evidence, demand testable predictions, demand that the music be heard and not merely imagined. The theme is fragile, vulnerable to skepticism, vulnerable to the abyss of the unprovable. Still, the theme persists, echoing across decades. It is the sound of a universe that longs for unity. It is the sound of physicists who cannot rest until the broken pieces are made whole. It is the sound of us as a species daring to believe that harmony is possible. And now, as we stand on the threshold of new discoveries, as 2025 whispers of dark energy, hints and swampland conjectures aligning with string predictions, the theme grows louder once more. The music stirs again, faint but insistent, a haunting refrain calling us deeper into the labyrinth. The theme has been stated. The universe is not what it seems. It is not particles but strings, not things but music. And if that is true, then everything, our science, our philosophy, our very place in existence, must be rewritten. The question lingers: if reality is music, then who or what is playing the strings? To understand why string theory captured imaginations, we must first linger in the ordinary world of physics, the landscape as it was before the first trembling vibrations of strings were ever considered. This is the ground floor of modern science, the foundation upon which we built everything we thought we knew about the universe. And at its core are two towering monuments: quantum mechanics and general relativity. Each is a masterpiece, a triumph of human intellect. Each is flawless in its domain. And yet, like two gods locked in eternal opposition, they cannot exist peacefully side by side. The conflict between them is the fracture line upon which string theory emerged. Quantum mechanics rules the microscopic world. It tells us that reality at its smallest scales is not smooth and predictable, but jittering, uncertain, probabilistic. Electrons buzz around nuclei not as little planets, but as clouds of possibility. Particles pop into and out of existence as if conjured from the void. The quantum world is a seething storm of probabilities, where nothing is certain until the moment of measurement. Relativity, by contrast, governs the cosmic stage. It tells us that space and time are not fixed, but bendable, stretchable fabric. Gravity is not a force, but the curvature of space-time itself. Stars orbit, planets fall, light bends, all because space-time curves around mass and energy. Relativity is elegant, deterministic, geometric. On their own, each theory works to exquisite precision. Quantum mechanics predicts the behavior of subatomic particles with astonishing accuracy. Relativity predicts the dance of galaxies and the bending of starlight around black holes. But when they collide, when we try to use both at once, the universe fractures. Take the singularity of a black hole. Here, mass collapses into infinite density, crushing space-time into a point. Relativity describes the curvature perfectly until it becomes infinite. Quantum mechanics, with its probabilistic laws, should govern what happens inside. Yet when the two are combined, infinities erupt, equations diverge, reason collapses. At the edge of a black hole, or at the birth of the cosmos in the Big Bang, our proudest theories fail us utterly. This is the ordinary world of physics before strings, a divided kingdom, fractured between the cosmic and the quantum. A world where we had no unifying language to speak of both. Enter the protagonists of our story. Gabriele Veneziano, a young physicist in 1968, stumbled across a formula that would later be seen as the birth of string theory. Trying to describe the scattering of particles bound by the strong nuclear force, he unearthed a mathematical expression that worked far too well to be coincidence. Later analysis revealed that this formula could be interpreted not as particles colliding, but as tiny strings vibrating. In his hands, physics accidentally uncovered the first hint of the music beneath the noise. Decades later, other figures would step into this unfolding drama. Edward Witten, one of the brightest minds in theoretical physics, would become string theory's most celebrated advocate. He saw in strings not just a mathematical curiosity, but the possibility of something grander, a theory of everything. But the stakes of their work were nothing less than the unity of all known physics. For if string theory could succeed, it could stitch together the great divide between relativity and quantum mechanics. It could tame the infinities that destroyed our equations at black holes and at the Big Bang. It could provide a single framework to describe all forces, all matter, all of existence itself. The setup of our story is thus not merely academic. It is existential. If physics could not unify its great theories, it would forever remain fractured, limited, incomplete. We would live in a universe whose deepest truths were forever beyond us, a cosmos stitched together with contradictions. But if string theory could unify them, then the dream of Einstein, the dream of a grand unified theory, could finally be realized. The ordinary world, however, resists change. For every dreamer who dared to imagine vibrating strings, there were skeptics who saw only fantasy. Physics was already filled with elegance, relativity's curved spacetime, quantum mechanics' shimmering uncertainty. Did we really need strings, invisible and unprovable, vibrating in dimensions we could never see? Still, the allure was undeniable. The mathematics of string theory demanded not 4 dimensions, but 10. Later, with refinements, 11. These extra dimensions were not fantasy, they were necessity. Hidden dimensions curled into tiny Calabi-Yau shapes, too small for us to see, but essential for strings to vibrate. Without them, the theory collapsed. Here, the ordinary world of physics began to crack. Because if these hidden dimensions were real, then the universe we inhabit is only a shadow of the greater cosmos. What we see is not all that is. Beyond our perception, folded into every point in space, lies a labyrinth of unseen dimensions. It is a haunting thought. And yet, in this haunting, there is hope. For if strings and dimensions could be real, then perhaps the fractures of physics could be healed. Perhaps the broken kingdom of relativity and quantum mechanics could be made whole. This is the setup of string theory's tale, a divided cosmos, desperate for unity, a handful of visionaries daring to imagine vibrations beneath reality. The stakes nothing less than the fate of physics itself. And then, the spark. A catalyst waiting to ignite, a revolution waiting to begin. Because in the midst of this fractured world, one discovery would change everything. The equations of string theory, once thought to describe the strong force alone, would be revealed to hold something far more profound. In the vibration of a single string, gravity itself was hiding. It begins, as revolutions so often do, with an accident, a mathematical curiosity, a formula too beautiful to ignore. By the early 1970s, physicists had already begun to explore Veneziano's strange equation, the one that seemed to describe particle scattering with uncanny elegance. The equation hinted at one-dimensional objects, strings, vibrating in unseen ways. But in those early years, few took it seriously. It was a mathematical toy, a strange coincidence, an outlier in the grand machinery of physics. And then came the revelation. In the vibrations of strings, physicists found something they were not looking for, a particle of spin 2, massless. This was no ordinary particle. According to the rules of quantum field theory, a particle with these properties behaved exactly like the graviton, the hypothetical quantum carrier of gravity. Gravity, the last great force that refused to be quantized, was hiding inside the mathematics of strings. This was the moment everything changed. String theory was no longer a tool for describing the strong nuclear force. It was no longer just an elegant accident. It had stumbled into the greatest mystery of them all, the unification of gravity with quantum mechanics. The physics community reeled. Here was a framework that did what no other theory had ever achieved. It tamed the infinities that arose when physicists tried to quantize gravity using ordinary methods. Where others diverged into nonsense, strings hummed with consistency. They provided a way forward, a way to imagine a universe where quantum mechanics and relativity did not oppose one another, but sang in harmony. This was the catalyst, the inciting incident in the tale of string theory, the discovery that these tiny, vibrating loops could, in principle, unite all of physics. But revolutions are never clean. At first, string theory was ridiculed. It seemed absurd. It required 10 dimensions of space. It demanded supersymmetry, an as yet undetected partner for every known particle. It had no experimental confirmation. To many, it was an embarrassment of riches, too complicated, too elegant, too strange. And yet the seed had been planted. For those willing to follow, string theory became more than mathematics. It became a vision of the universe. The catalyst grew stronger in 1984 when what is now known as the first superstring revolution erupted. A group of theorists, including Michael Green and John Schwartz, demonstrated that string theory could be free from deadly mathematical anomalies that had plagued other attempts at unification. With that paper, the tide shifted. Overnight, string theory transformed from an obscure curiosity into the hottest idea in physics. Conferences buzzed with talk of strings. Physicists abandoned careers in other fields to chase this new dream. The allure was irresistible, a single framework capable of containing all forces, all particles, all of reality. It was the kind of theory Einstein had sought but never found, a theory of everything.
Imagine the gravity of that moment. For centuries, science had sought to unify. Newton showed that the apple falling to Earth and the moon orbiting in the sky were ruled by the same law. Maxwell showed that electricity and magnetism were two sides of one coin. The dream of unity was the heartbeat of physics, and now strings offered the ultimate unification.
The excitement was electric. Physicists spoke of strings weaving the cosmos like threads on a loom. They imagined Calabi-Yau manifolds, complex geometric shapes hidden in the extra dimensions where strings could vibrate in different modes. Each vibration gave rise to a particle, each resonance a force of nature. The world of particles, the zoo of quarks and leptons and bosons, suddenly looked like the surface ripples of a deeper symphony. Beneath them, strings pulsed, their harmonics shaping the visible universe. But this was not only a scientific revolution, it was philosophical. If strings were real, then the universe was not built of indivisible particles at all. It was music, it was vibration, it was resonance humming in dimensions beyond sight. And with that realization, the stakes grew higher. Because if string theory was right, then our picture of reality, our four-dimensional space-time, our collection of particles, our laws of physics themselves, was only a shadow of something deeper. This was the ignition point. The ordinary world of fractured physics, quantum mechanics on one side, relativity on the other, had been pierced. The impossible was now possible. The cracks in the foundation had revealed a hidden staircase, descending into a labyrinth no one had ever walked before. Yet even in the glow of revelation, shadows gathered. For with every door string theory opened, another slammed shut. The theory was beautiful, but it was slippery. It promised unification, but it required faith in unseen dimensions, unseen particles, unseen symmetries. Still, there was no turning back. The catalyst had ignited the revolution. The world of physics had been transformed. The question was no longer whether string theory was intriguing. The question was whether it could deliver on its promise or collapse under the weight of its own elegance. And so the debate began. Every great revolution carries within it the seeds of doubt. String theory's ascent in the mid-1980s was breathtaking, but even as physicists rushed to embrace it, others hesitated. A chorus of questions rose above the symphony of excitement. Was this the long-sought theory of everything or a mirage shimmering on the horizon? The debate unfolded in lecture halls, in papers, and in quiet conversations over coffee in dusty university corridors. On one side stood the visionaries, who saw in strings the most promising unification in history. On the other side stood the skeptics, unwilling to place their faith in a theory that required dimensions no one had ever seen, particles no one had ever measured, and mathematics that seemed always to move the goalposts. The strength of string theory was also its weakness. It was too perfect. The mathematics of vibrating one-dimensional strings fit together like an intricate tapestry, banishing anomalies that had plagued rival theories. It unified gravity with quantum mechanics. It made infinities manageable. It wrapped the fundamental forces into a single framework. But for all its elegance, string theory offered no immediate way to be tested. Science demands falsifiability. A theory must risk failure. It must make predictions that can be measured, so that experiments may declare it wrong or right. And here lay the deepest concern. If string theory's extra dimensions were compacted into scales smaller than an atom, how could we ever hope to see them? If supersymmetric partners existed but remained undiscovered in particle accelerators, how long would we wait? For every passionate advocate, there was a voice warning that string theory could become a mathematical cathedral, majestic, beautiful, and utterly uninhabited. The debate was not just scientific, but existential. Some physicists argued that the pursuit of string theory was driven as much by aesthetic desire as by empirical rigor. The idea that the universe is built not from particles but from strings vibrating in higher dimensions was seductive, too seductive perhaps, for beauty is no guarantee of truth. And yet, string theory's defenders had their own arsenal of arguments. They pointed to its uncanny ability to absorb and resolve problems that other frameworks could not touch. The theory's requirement for supersymmetry, for example, dovetailed neatly with efforts in particle physics to explain the stability of the Higgs boson's mass. Its extra dimensions found surprising echoes in mathematics, generating insights into fields far beyond physics. But perhaps the most intriguing defense of string theory came in the form of a new connection to cosmology. By the mid-2020s, some researchers had begun to claim that string theory could shed light on dark energy, the mysterious force accelerating the expansion of the universe. In 2025, tentative claims emerged that observational data from cosmic surveys could align with string theory's predictions, specifically with constraints arising from the so-called swampland conjecture. The swampland conjecture was itself a strange beast, a framework designed to sift through the vast landscape of possible string theory solutions, discarding those too inconsistent with a stable universe. For years, critics had mocked the theory's sprawling landscape of 10 to the power of 500 possible vacua, so many possible universes, each with different laws of physics, that string theory seemed to predict everything and therefore nothing. But swampland arguments suggested that not all of these vacua were viable. String theory, if married to observational data, might yet make concrete predictions about the cosmos. The debate intensified. Advocates hailed these links to dark energy as a sign that string theory was inching closer to testability. Skeptics dismissed them as desperate attempts to tether speculation to data. But beneath the surface, the struggle was deeply human. Theorists who had devoted their lives to string theory clung to its promise, unable or unwilling to let go of the dream. Younger physicists wrestled with whether to stake their careers on a theory that could be the greatest breakthrough in history or a grand dead end. Even in the beauty of string theory, there were unsettling philosophical consequences. If extra dimensions were real, then the universe we see is only a fraction of reality. If the string landscape existed, then our cosmos was not unique, but one among an unfathomable multitude of possible universes. The idea of a multiverse emerged, not as science fiction, but as a logical implication of the mathematics. And here the debate spilled into the philosophical. Could we ever prove or disprove a multiverse? Could science survive if its ultimate theories became matters of belief rather than measurement? Still, the allure remained. Strings beckoned like threads dangling from the hem of the universe. To pull on them was to risk everything, but to ignore them was unthinkable. In the late-night hours of research labs and the hushed auditoriums of conferences, the battle raged on. Advocates spoke of unity, of the dream of a single framework binding all forces. Skeptics warned of castles built in clouds, and yet the choice was inevitable. To remain in the ordinary world of fractured physics, content with quantum mechanics on one side and relativity on the other, was to accept incompleteness. To follow the strings was to plunge into the unknown, to chase shadows and symmetries, to risk wandering forever in a mathematical labyrinth. The debate reached a fever pitch, and then, slowly, the choice was made. A new generation of physicists stepped forward, willing to take the leap. The path was chosen. The descent into the stringed abyss had begun. The choice has been made. The doubts, the hesitations, the warnings, they linger still, but they no longer hold the center of the stage. With the promise of unification shining like a star ahead, physics takes the leap. The journey leaves behind the ordinary landscape of fractured theories and steps fully into the realm of strings. This is the moment of commitment, the point of no return. To walk into the world of string theory is to walk into a mirror universe of hidden shapes and folded spaces. It is not the four-dimensional reality of daily life, nor even the smooth space-time of Einstein's relativity. It is something stranger, more intricate and far more unsettling. At its core lies the idea of Calabi-Yau manifolds. These are not objects one can see or touch, but mathematical structures, six-dimensional spaces curled up inside every point of the universe. Strings vibrate within them, their harmonics determined by the manifold's topology. Each fold, each twist, each compacted shape gives rise to different particles, different forces, different physical laws. Imagine looking at a violin. Its strings can vibrate in countless ways, but the body of the instrument shapes and amplifies the music. Change the violin and you change the sound. In string theory, the Calabi-Yau manifold is the instrument. The universe we inhabit, the zoo of particles, the four forces of nature, the fabric of reality itself, emerges from the hidden geometry of this extra-dimensional space. It is both elegant and terrifying, for it means that what we perceive as immutable laws are not fundamental at all, but contingent on the shape of a hidden geometry we cannot see. Reality itself, in this view, is architecture, crafted not by divine design but by the mathematics of folded dimensions. But the deeper one ventures into this world, the stranger it becomes. Because string theory does not only suggest hidden dimensions, it also whispers something far more radical, that our universe might be a hologram. This is the holographic principle, one of the most startling revelations to emerge from the string landscape. At first glance, it sounds like science fiction, but its roots are deep in the mathematics. It begins with black holes. Stephen Hawking showed that black holes radiate, slowly evaporating over time. Yet if they evaporate, what happens to the information that fell into them? If it is destroyed, as Hawking first suggested, then quantum mechanics itself is broken. Information, after all, must be preserved. To resolve this paradox, theorists turned to strings. What they found was astonishing. In certain formulations of string theory, a black hole's information is not destroyed, but encoded on its event horizon, the two-dimensional surface at its boundary. The three-dimensional contents of the black hole are, in effect, a holographic projection of data written on its surface. From this insight, a radical idea was born. What if the universe itself is holographic? What if everything we experience as three-dimensional, space, depth, even time, emerges from data inscribed on a distant boundary? The holographic principle is one of string theory's most profound contributions, and one of its most unsettling. It suggests that reality as we know it is not fundamental. It is emergent. The cosmos could be a projection, like a film on a screen, its true description etched on some unseen surface in higher dimensions. Here, in this upside-down world, material certainty begins to crumble. The ordinary laws of physics feel like shadows. What is real and what is illusion? Are we explorers of the cosmos, or dreamers wandering through a hologram? To the physicists who embraced this descent, there was exhilaration. The holographic principle gave them tools to calculate black hole entropy, to preserve the sacred rule of information conservation, to tame paradoxes that had tormented physics for decades. But it also forced them to confront a deeper philosophical unease. If reality itself is emergent, if dimensions and particles are illusions born of vibrations and encodings, then what is truly fundamental? This is where the descent into the world of strings takes on its full weight. It is no longer about unifying gravity with quantum mechanics. It is about confronting the possibility that everything we perceive, atoms, stars, even time itself, might not exist in the way we think. That they are not bricks of a building but notes in a song, shadows of a projection, echoes of a geometry humming just beyond our reach. And yet, in this darkness, companions appear. Alongside the pioneers of string theory, new generations of thinkers join the quest. Mathematicians explore Calabi-Yau manifolds, mapping their endless variations. Cosmologists test the edges of the holographic principle, probing the cosmic microwave background for signatures of stringy physics. Philosophers wrestle with the implications, wondering whether consciousness itself might be tied to emergent holographic layers. Allies gather, even as riddles multiply. Each discovery opens new doors, but each door reveals a new maze. For every problem solved, 1,000 new mysteries emerge. The descent into the stringed abyss is not a journey toward clarity, but into deeper enigma. Still, the path is set. There is no retreating to the ordinary world of fractured theories. Physics has committed itself to this strange new landscape of strings, extra dimensions, and holographic whispers. And in this inverted realm, the true adventure begins. The descent into the stringed realm has begun. But every great journey carries with it a second story, a quieter current flowing beneath the main adventure. The science is the A story, the equations, the dimensions, the search for unification. The B story, however, is more human. It is the undercurrent of philosophy, the reflection of meaning, the thread of wisdom that mirrors the grand discoveries with intimate resonance. To speak of string theory is not merely to speak of mathematics. It is to wrestle with questions as old as humanity. What is reality? Why is there order in chaos? Is the universe intelligible because it is built to be, or because our minds shape it so?
This B story is carried not by equations but by voices. Imagine a veteran physicist, grey-haired, eyes heavy with years of wrestling with mysteries, sitting quietly in a lecture hall after the crowd has dispersed. The chalkboard behind him is filled with symbols that might as well be hieroglyphs to outsiders, but to him they are music, half heard. He speaks softly. The universe is not made of things. It is made of patterns, and we, humans, are patterns too.
Such reflections do not make it into journals or Collider data reports, but they linger, whispered over coffee or scribbled in the margins of notebooks. They are the soul of the B story, the recognition that string theory is not only about physics, but about what it means to exist. The emergence of M theory in 1995 exemplifies this deeper current. For years, physicists had been divided among 5 different versions of string theory, each elegant, each self-consistent, but seemingly incompatible. Then Edward Witten proposed that these 5 theories were not rivals at all, but facets of a deeper framework, M theory. Suddenly the divisions were seen as illusions, fragments of a single hidden whole. This was more than a mathematical breakthrough, it was a parable. What had seemed fractured was unified. What had appeared contradictory was revealed to be harmonious. The lesson extended beyond physics. Perhaps divisions in knowledge, divisions in philosophy, even divisions among people are not final. Perhaps they are illusions, shadows of a deeper unity we cannot yet see. Here lies the B story's quiet power. String theory mirrors our own human struggles for meaning. Just as physics seeks harmony between relativity and quantum mechanics, between gravity and particles, so too do we seek harmony between the chaos of daily life and the order we long for in our souls. The deeper string theory probes, the more it evokes echoes of ancient thought. The Hindu concept of Brahman, the underlying unity beneath all appearances. The Taoist vision of the Tao, the ineffable flow binding opposites. Even the Platonic idea of forms, eternal archetypes shaping the shadows of our reality. It is as though string theory, in its quest for equations, has stumbled into the same territory mystics and philosophers have walked for millennia. And yet the B story does not simply celebrate unity, it also carries the burden of infinity. For if M theory is correct, if strings vibrate across dimensions and generate not one universe but a vast landscape of possible universes, 10 to the power of 500 or more, then our cosmos may be but one note in an infinite symphony. This is both exhilarating and terrifying, for it suggests that everything we know, everything we are, is not necessary but contingent. In another universe, the strings vibrate differently, the dimensions fold in new ways. And physics itself writes a different story. In some universes, stars never form. In others, time unravels before life can arise. In ours, improbably, consciousness has bloomed. The B story forces us to ask, what does it mean to exist in a universe that is not unique, not privileged, not ordained? Are we diminished by this possibility or ennobled? The reflections deepen when we consider consciousness itself. If reality is emergent, if dimensions and particles are mere projections of strings vibrating in higher spaces, then what is the mind? Is thought itself a vibration, a resonance emerging from neural strings woven into biological form? If so, then consciousness may not be a ghost in the machine, but a harmony rising from the same cosmic strings that give rise to stars. In this way, the B story becomes a meditation on balance. Just as neutrons stabilize nuclei, just as strings stabilize infinities, so too must humans find balance within themselves. Stability emerges not from stasis but from tension, opposites held together, forces woven into fragile harmony. The physicist's chalkboard is erased at the end of the day, but his words linger. We do not seek strings because we want control. We seek them because we long to know if reality is woven as we are, fragile, temporary, yet part of something endless. The B story thus runs parallel to the scientific quest. It is less visible, but no less real. It reminds us that the pursuit of string theory is not only about equations and predictions. It is about humanity's eternal hunger for meaning, unity, and transcendence. As wonders unfold in the string landscape, extra dimensions, M theory's harmonies, holographic whispers, so too does the B story bloom. But even in its wonder, shadows lengthen. For just as the string landscape multiplies possible universes, so too does obscurity grow. The more we learn, the less certain we become. The revelry of discovery is tempered by the encroachment of doubt. Is the beauty we see in strings a reflection of reality or of ourselves? The B story does not answer. It lingers in the question. It leaves us suspended between awe and uncertainty, between revelation and mystery. And as this undercurrent flows, the stage is set for the next act. The fun begins, the dazzling display of possibilities, the strange lives of strings, the playful yet haunting exploration of realities that may be. But beneath it all, the quieter story continues. Humanity's search not just for physics, but for a mirror of itself in the cosmos. This is the moment when string theory stretches its limbs and reveals its strangest shapes. The promise of the premise. What happens when the universe is not made of particles, but of tiny vibrating strings weaving hidden realities? It is here, in this carnival of cosmic possibility, that the theory blossoms into both its most beautiful and its most bewildering forms. Imagine first the multiverse, a landscape of universes stitched together not by stars but by strings. Each universe emerges from a different vibration, a different folding of extra dimensions. One cosmos may hum with laws that allow life, another collapses before it begins, another unfolds with alien symmetries beyond comprehension. String theory suggests that our universe is not the only game in town. It is one note in a vast orchestra, and we are lucky or doomed to be listening to this particular melody. Now, enter the brain worlds. A brain, short for membrane, is not an object we can touch, but a vast sheet or surface floating in higher dimensional space. Some versions of string theory propose that our entire universe may be trapped on one such brain, like a painting on invisible canvas. The stars, the galaxies, even the breath in your lungs, all confined to this four-dimensional bubble. And yet, just beyond our perception, another brain could drift, parallel to ours, separated by only a microscopic gap in an unseen dimension.
If two brains were ever to collide, theorists suggest, the result could be cataclysmic. Entire universes might be born in the flash. Some even speculate that our own Big Bang was not the birth of everything, but the echo of such a cosmic collision. Imagine it, the universe not as a singular beginning, but as the ripple of brains colliding in eternal cycles, each impact igniting a new reality.
The fun of string theory is not always playful. Sometimes it is unsettling, even terrifying. Black holes, those ravenous monsters devouring everything in their reach, become test sites for string theory's boldest claims. The entropy of a black hole, once an enigma, can be explained by the vibrations of strings at its event horizon. In this view, the edge of a black hole is not an abyss, but a vast tangle of strings encoding the information of everything that falls inside. And through this stringy lens, we begin to see black holes not as devourers, but as libraries, storing reality in microscopic loops.
Then there is the holographic principle. From string theory emerges one of the most radical ideas in modern physics, that our three-dimensional world may be nothing more than a projection, a hologram, cast from information inscribed on a distant boundary. We live, perhaps, in the shimmering illusion of a deeper reality. To walk through your city streets, to touch the hand of someone you love, may be to wander inside a projection, real to us, but only a shadow of hidden dimensions beyond.
The playful possibilities of string theory also touch the everyday. If strings vibrate, then perhaps their harmonies shape everything from the mass of the proton to the structure of space-time. The entire table of elements, the chemistry of life, the emergence of stars, these may all be the music of strings plucked on the harp of the cosmos. Reality itself becomes a symphony, and we are both listeners and participants in its unending concert. In this carnival of strings, experiments occasionally tease us with glimpses of what might be. In 2011, the opera experiment in Italy shocked the world with a claim that neutrinos had traveled faster than light. For a brief moment, physicists wondered if tachyonic echoes of string theory had finally been glimpsed. The result turned out to be a faulty cable, but the fever it stirred revealed something profound. Humanity is always ready to believe in the impossible, to entertain the game of reality itself breaking its rules. And more recently, in 2025, string theorists point to subtle signatures in dark energy and scattering amplitudes, mathematical whispers that strings may indeed be inevitable. These are not confirmations, but they are tantalizing. They suggest that the fun and games of string theory may not be mere play after all, but the foreshadowing of discoveries to come. Still beneath the wonder lies unease. For each dazzling possibility, another door opens onto confusion. If universes multiply endlessly, what meaning has our own? If brains collide in infinite cycles, is our history unique, or just one of countless repetitions? If reality is holographic, are we beings of depth or shadows on a screen? The fun is intoxicating, but it is also dizzying. Each playful vision carries with it the possibility of annihilating what we thought we knew. And yet, humanity has always thrived in this space of uncertainty. The same imagination that paints string landscapes also paints myths, philosophies, and dreams. In the funhouse of string theory, science and wonder fuse. The strings vibrate not just in equations, but in the human mind. The carnival goes on, strings linking quantum fields to gravity, strings whispering of wormholes, strings suggesting that space-time itself is emergent, not fundamental. Every new possibility is a game, but not a trivial one. These games reveal truths, or at least paths to truths, that could transform how we see ourselves in the cosmos. And just when the spectacle seems brightest, just when the music of strings feels unstoppable, a shift comes. The games, after all, cannot last forever. The playfulness reaches its peak, but in the shadows a question looms. What if the strings fray? What if the very evidence that has tantalized us begins to unravel? The carnival fades into silence. The lights dim. The exhilaration gives way to unease. For just beyond the revelry lies a turning point, a confrontation with doubt. The midpoint approaches, the false victory where string theory seems triumphant, only to face its greatest adversaries. At last, the dream seems within reach. After decades of speculation, ridicule, and debate, string theory stands on the brink of triumph. For a fleeting moment, it feels as though the universe has revealed its secret code and humanity has cracked the lock. Consider the audacity of the claim that every particle, every force, every star and black hole and galaxy arises not from point-like dots, but from tiny strings vibrating in multidimensional space. The elegance of the mathematics is intoxicating. Where relativity and quantum mechanics have fought a bitter, century-long duel, strings step in as peacemakers. Gravity, once impossible to reconcile with quantum theory, finds its place in the vibrations of these filaments. The four fundamental forces of nature, the strong nuclear, weak nuclear, electromagnetic and gravitational, suddenly appear not as separate empires, but as movements of the same symphony. This is the false dawn, the moment when the theory's beauty seduces even the skeptics. It is a triumph that feels almost inevitable. By the mid-1990s, Edward Witten and other visionaries unveiled M-theory, a sweeping unification of the five competing versions of string theory. What once seemed fractured now coalesced. Strings were no longer the sole players. Higher dimensional objects called brains joined the stage. A deeper, more mysterious framework emerged, suggesting that reality itself might be a vast 11-dimensional edifice. For many, it was a revelation. The squabbling children of string theory had grown into a single, awe-inspiring colossus. Then, in the years that followed, new clues began to surface. Clues that hinted this grand vision was not just mathematical fantasy. The holographic principle, born from string theory's equations, provided a startling explanation for black hole entropy. It suggested that the three-dimensional world we inhabit may, in truth, be a projection of information inscribed on a distant, lower-dimensional surface. What once sounded like science fiction suddenly seemed plausible, even necessary. And then, more recently, whispers from the cosmos itself. In 2025, researchers analyzing the delicate fingerprints of dark energy began to find patterns that appeared consistent with predictions from string theory's so-called swampland conjecture. For decades, critics had dismissed string theory as untestable, a mathematical cathedral with no doors to the real world. Yet here were cracks in that argument, faint though they were. Observational data, however tentative, suggested that string theory might finally brush against reality. At the same time, scattering amplitudes in high-energy particle experiments began to reveal tantalizing structures. Physicists argued that the only framework capable of explaining the elegance of these results was string theory. Some even declared strings inevitable. For the faithful, this was vindication. For the undecided, it was enough to inspire awe. The triumph feels intoxicating. To believe that we might at last have glimpsed the theory of everything, a single all-encompassing law beneath the chaos of existence, is to believe in something almost divine. Imagine the implications. Not only would we understand the particles and forces of our universe, but perhaps the birth of the cosmos itself. The Big Bang, once shrouded in mystery, could be recast as a vibration, the pluck of a cosmic string echoing across dimensions. Philosophers too felt the tremors. If string theory is true, then the universe is not a collection of cold, dead particles, but a vast, living harmony. Reality itself would be music, silent to our ears but resonating in the very fabric of space-time. The ancients spoke of the music of the spheres. String theory seemed to offer its modern counterpart, the music of existence.
And yet, even at this moment of victory, shadows lengthen, for triumph has a way of hiding its own cracks.
The deeper one peers into the mathematics of strings, the more unsettling questions emerge. The so-called landscape problem rears its head. String theory predicts not one universe, but 10 to the power of 500 possible universes. Each corresponds to a different way of curling the extra dimensions, each with its own laws of physics. But if so many realities are possible, why do we live in this one? Is our universe unique, or merely one bubble in a frothing sea of countless others? And if string theory allows every possible cosmos, does it explain anything at all? Or does it simply drown explanation in an infinity of options? The triumph, too, depends on mathematics that few can fully grasp. It is so elaborate, so abstruse, that even within the community of physicists, only a rare few dare to claim mastery. For the rest, belief in string theory sometimes feels more like faith than science. Still, the midpoint lingers as a false victory. String theory has never seemed stronger, never more compelling, never closer to becoming reality. For the moment, it feels like we stand on the mountaintop, the clouds parting to reveal the infinite landscape of truth. But the mountaintop is treacherous. Triumph breeds complacency, and the higher we climb, the steeper the fall. Because just beyond this shining moment, the enemies of string theory gather. The experimental failures at the Large Hadron Collider, the vanishing hope for supersymmetric particles, the gnawing unease of untestability. Even as string theorists declare victory, critics sharpen their knives. The midpoint is sweet, but it is fleeting. The cracks are widening, the storm is building, and the victory we savor may be little more than an illusion. And so we leave the false dawn with a question. If string theory truly unites the universe, why does its beauty fracture under scrutiny? The glow of triumph does not last. In science, every dawn of discovery is shadowed by questions, doubts, and the relentless demand for evidence. And in the years after string theory's apparent ascent, the shadows lengthen. The critics have been waiting. For decades, they have tolerated string theory's dominance, watching as it consumed conferences, research grants, and the imagination of generations of physicists. They have waited patiently for the moment when the theory, so bold in its promises, would fail to deliver. Now that moment begins to arrive. The cracks are no longer faint hairlines, they are widening fissures. The first blow comes from experiment. At the turn of the century, anticipation swirled around the Large Hadron Collider, a machine buried deep beneath the Franco-Swiss border, the most powerful particle accelerator ever built. It was supposed to be string theory's proving ground. Supersymmetry, the elegant prediction that every particle has a heavier partner, was expected to emerge in the collider's data. These sparticles would not only confirm string theory but also help solve the mystery of dark matter. But when the LHC roared to life, the detectors remained silent. No supersymmetric partners appeared. The standard model of particle physics, battered and incomplete, stood unshaken. String theory's first great hope evaporated. Then came the second blow. The landscape problem refused to be tamed. With 10 to the power of 500 possible universes predicted by string equations, the theory seemed to dissolve into ambiguity. How could a framework that permits everything truly explain anything? It was like a map so vast and detailed, it obscured the very path it was meant to illuminate. Critics sneered. This wasn't science. It was philosophy masquerading in the clothes of physics. Inside the community, frustration grew. Younger physicists whispered that string theory had hijacked the field, consuming decades of talent without a single empirical triumph. They asked the uncomfortable question aloud: is this a theory at all, or just a mathematical religion? Even within the halls of string theory itself, unease spread. The theory's most ardent defenders admitted that predictions were elusive, its equations too pliable. Some began to explore alternatives: loop quantum gravity, emergent spacetime, approaches that sought to reconcile relativity and quantum mechanics without invoking vibrating strings in hidden dimensions. The blows kept falling. Hawking himself, who once flirted with string frameworks, delivered scathing remarks on time travel and causality, raising questions about whether tachyonic instabilities buried within the math signaled that the whole edifice was unstable. In laboratories, string theory's empirical silence grew deafening. Particle collisions revealed nothing new. Dark matter remained invisible. Gravitational wave observatories, once hoped to glimpse traces of exotic string phenomena, recorded only the expected echoes of colliding black holes. The dream of a theory of everything dimmed, replaced by the cold stare of reality. We may never be able to prove string theory, not now, not ever. For a theory that aspired to explain all of existence, the absence of evidence was damning, and yet the allure refused to die. The mathematics still shimmered with elegance, each equation singing of unification, of symmetries too beautiful to abandon. But beauty is a dangerous ally. History has shown us again and again that nature does not bend to human notions of elegance. Ptolemy's epicycles were beautiful too, and utterly wrong. The bad guys close in not only from outside but from within. The doubts take root in the minds of the faithful. Physicists who once devoted their lives to the string landscape begin to waver. Some leave the field altogether, retreating into data-driven physics where results can be measured, verified, known. Others remain, clinging to the possibility that the next experiment, the next telescope, the next decade will vindicate the dream. But with each passing year, the silence grows heavier, and still the universe seems indifferent. Black holes spin, galaxies expand, dark energy accelerates the cosmos into the void, all without revealing a single string. For the first time, the possibility must be confronted. What if string theory is wrong? What if decades of brilliance and labor have been spent chasing a mirage, a phantom woven from mathematics and hope? The pressure builds, the skepticism sharpens, the storm gathers. It is no longer enough to speak of harmony and beauty. The world demands proof, and string theory has none. The very triumph that once felt so secure now becomes its most dangerous illusion. A false victory lulls the seeker into complacency, only to awaken them in the jaws of doubt. And as the walls close in, one haunting question emerges. If string theory fails, what then becomes of our dream of unification? The dream collapses. For years, string theory held itself aloft, buoyed by elegance, by the conviction that beauty must correspond to truth. But beauty is not enough, and the walls are closing in. The physicists who once spoke with fervor now mutter with hesitation. Their equations remain flawless, their mathematics dazzling. Yet every test of nature, the only true arbiter, remains mute. The Large Hadron Collider has run for over a decade, producing oceans of data, and still not a whisper of supersymmetry, not a trace of exotic particles, not a single tremor to suggest the extra dimensions string theory requires. The silence is deafening. One by one, the pillars fall. Supersymmetry, once string theory's greatest ally, is increasingly seen as a failed prophecy. The promise that every particle in the standard model has a heavier twin has been swallowed by the void. The sparticles are not there. The dream that they might reveal themselves just beyond the next energy threshold has become a hollow refrain. The cosmological hopes fade as well. String theory was supposed to illuminate dark energy, the mysterious force driving cosmic acceleration. Instead, the theory drowns in its own excess, a landscape of 10 to the power of 500 possible solutions, each corresponding to a different universe with different laws. What began as a path to truth becomes a labyrinth with no exit. If every possibility exists, then the theory predicts nothing. It becomes not a lens, but a fog. Even the faithful begin to falter. A younger generation of physicists, unwilling to tie their careers to an unfalsifiable framework, drifts elsewhere. To data-rich astrophysics, to practical quantum computing, to fields where experiment still holds sway. String theory retreats to a corner of theoretical physics, still dazzling, still ambitious, but increasingly isolated. The critics sharpen their knives. It is not physics, they say, it is mathematics wearing physics clothes. The harshest voices call it a cult of beauty, a cathedral built on symmetry but empty of substance. The charge stings because it cuts close to truth. Within the theory itself, a malaise sets in. Some speak openly of failure, of decades lost to a mirage. Others quietly shift their work toward adjacent fields. Holography, quantum information, approaches that borrow from string mathematics without committing to the whole edifice. Still, others cling fiercely, unable to relinquish a lifetime's devotion, insisting that vindication will come, even if it lies beyond their lifetimes. But the all-is-lost moment is not just about the science, it is about the soul. String theory's collapse threatens not only a framework, but the very dream of unification. Humanity's deepest yearning has always been to find the hidden order of the cosmos, a single principle that binds all things. Einstein spent his final years chasing it, and generations followed. String theory was supposed to be the culmination, the long-sought theory of everything. If it fails, what then? Are we condemned to live in a fractured universe where quantum mechanics and relativity remain forever irreconcilable, two strangers who will never speak? The despair deepens when one considers the possibility that the flaw is not in string theory, but in human limitation itself. Perhaps the truths of the universe are beyond us. Perhaps our mathematics, our machines, our imagination cannot pierce the veil. Perhaps the dream of unification is not destiny, but delusion. And in the darkest hours, the whispers grow louder. Was it all for nothing? Imagine the physicist staring at a chalkboard filled with strings of equations that bend and twist into infinities, knowing that no experiment can prove or disprove them. Imagine the sense of futility, the crushing weight of realizing that nature may never answer. The blackboard becomes a tombstone, the symbols etched into it like epitaphs for a dream. The collapse echoes beyond physics. If the deepest theory we have offers no predictions, no tests, no way to know, what does that say about knowledge itself, about truth? If string theory is unfalsifiable, then is it science, or is it philosophy, art, myth disguised as mathematics? For the seeker, this is the nadir. The point where the journey feels pointless, where the light is extinguished and only darkness remains. The theory of everything dissolves into the theory of nothing. And yet, in this abyss, something stirs. Not hope, not yet, but the seed of transformation. Because despair forces honesty. When all illusions are stripped away, when every false promise has crumbled, what remains is the raw question itself. The hunger for understanding does not die. It grows sharper in the void. But for now, the void is absolute. String theory, the great unifier, lies broken under the weight of its failures. The equations still shimmer, but they shimmer like ghosts, haunting, beautiful, untouchable. The dream is gone. The castle has fallen. The seekers stand amid the ruins, asking the only question left. What if reality cannot be strung together at all? The silence deepens. In the aftermath of collapse, when the dream of string theory has unraveled into threads scattered across the floor, there is no triumph, No clarity, only emptiness. A cosmos once thought to be a symphony of vibrating filaments feels instead like a mute mechanical void. The music has stopped. The human spirit, so long sustained by the conviction that the universe has meaning, that its laws must fit together into a single, harmonious whole, now confronts the possibility that there is no harmony, no final unity, just fragments. It is in this desolation that the dark night of the soul begins.
For centuries, physics has thrived on certainty, on discovery, on the exhilaration of solving puzzles and unveiling secrets. From Newton's clockwork heavens to Einstein's space-time fabric, from Bohr's atom to the Standard Model, each step has brought triumph. But here, in the long shadow of string theory's faltering, there is no triumph. There is only the slow realization that perhaps the puzzle cannot be solved at all.
Imagine looking into the night sky and knowing that behind every star lies not one truth, but countless possible truths, each equally valid, each equally unreachable. A universe of infinite possibilities is not liberating. It is suffocating. It leaves us adrift, unable to anchor ourselves to a single knowable reality. And in this bleakness comes the fear. What if the quest itself has been misguided? What if the hunger for unity is nothing more than a projection of the human mind, a desire for order where none exists? This thought cuts deeper than the failure of any theory. It strikes at the heart of human purpose. For if the universe does not yield to reason, then what role do we play? Are we explorers of truth, or dreamers chasing illusions, spinning myths out of mathematics? The halls of academia echo with doubt. Older physicists who have given their lives to the string dream face a reckoning. Younger scientists wonder if they are inheriting not a frontier, but a graveyard. Some drift away entirely, to computer science, to finance, to fields where progress feels tangible. Others remain haunted, still tracing equations on blackboards, but with less conviction, their chalk scratching like a requiem for a lost vision. Yet despair has a strange power. It forces humility. It strips away arrogance, leaving behind only the raw, unadorned questions. In this darkness, the ego dissolves. What remains is the essence of inquiry itself, the refusal to stop asking even when the answers may never come. And from that humility arises something unexpected, a glimmer. It comes first as a whisper, then as a spark. In the most unlikely corners, hints appear that perhaps string theory is not entirely lost, that within its apparent failures may lie a deeper truth. Consider the holographic principle, born from string mathematics. Once dismissed as a curiosity, it begins to reshape how we think about space and time themselves, suggesting that our universe might be a projection from a lower dimensional reality, or quantum information theory, which borrows tools from string frameworks to unravel mysteries of black holes, offering new ways to think about entropy and information preservation. These offshoots, though not full vindication, reveal that the theory's tendrils still reach into fertile ground. Even in cosmology, whispers persist. Some argue that the landscape of string vacua, once mocked as a swamp of untestable universes, may actually echo the vastness of a multiverse. And in 2025, new studies of dark energy hint at correlations with string-derived models, delicate threads of evidence, faint but tantalizing. It is not a resurrection, not yet, but it is enough to suggest that perhaps the darkness is not total. Perhaps the music has not ended, only changed its key. The dark night of the soul is not just about science, it is about the human condition. It is the moment when hope dies, only to be reborn in a new, humbler form. It is the recognition that truth may not be simple, may not be elegant, may not even be comprehensible in the way we desire. And yet, the search itself is worth everything. The narrator's voice turns inward here, contemplating not the equations but the hunger behind them. Why do we seek? Why does it matter to us whether strings exist, whether the cosmos is woven or fragmented? It matters because in seeking we affirm something essential about ourselves. That even in despair we refuse to surrender. That even if the truth lies forever beyond our grasp, the pursuit defines us. The darkness teaches us that science is not about certainty, it is about persistence. It is about standing in the void and continuing to ask questions, even when the void does not answer. And so, from the ashes of collapse, a strange strength begins to stir. It is not triumph. It is not vindication. It is the quiet resilience of a species that refuses to give up. The dark night of the soul is never the end. It is the crucible in which transformation is forged. The chalkboards remain covered in strings of symbols. The papers still circulate, theories still debated. The dream of unification is not dead, merely tempered. No longer an expectation, but a possibility. Fragile, distant, worth chasing nonetheless. Because in the silence of despair, the universe still whispers. The cliffhanger rises here, subtle but potent. If the dream of string theory is not truly dead, what new vision will rise from its ashes? The darkness does not last forever. From the silence, from the void where certainty collapsed and hope seemed extinguished, a new light begins to flicker. Not the blinding brilliance of triumph, but the softer, steadier glow of integration. It is the moment when science, humbled by its failures, learns to listen not only to its equations, but to its philosophy, its humanity, its deeper questions. Here the story bends. The scattered threads that once unraveled now begin to weave together, not into a perfect tapestry, but into something sturdier, more resilient, more honest. For decades, string theory promised everything: the unification of forces, the resolution of quantum gravity, the key to the ultimate laws of nature. When that promise faltered, despair set in. But in the ruins of that overreach lies something vital: the realization that string theory does not have to be the final truth to matter. It can be a bridge, a language, a metaphor that guides us closer to truths we cannot yet name. This is the synthesis, the breaking into three. The point where science and philosophy, once kept at arm's length, begin to converge. Physicists, once disheartened, start to find unexpected uses for string frameworks. In condensed matter systems, tools derived from string theory illuminate the strange behavior of superconductors and quantum fluids. In black hole physics, holography, born from strings, offers profound insights into how information survives at the edge of oblivion. Even in mathematics, string theory's equations generate structures and symmetries that astonish pure mathematicians, hinting at connections far deeper than physics alone. And beyond the equations, a philosophical realization takes root. The universe may never hand us a neat, elegant theory of everything, but perhaps that was always the wrong dream. Reality may not be a single monolithic truth waiting to be discovered, but a shifting interplay of truths, each valid in its own domain, each incomplete on its own. String theory teaches us humility, that we are not masters of the cosmos, but apprentices fumbling toward comprehension. There is a strange power in this humility, for when arrogance falls away, what remains is wonder. The human story has always been one of integration. We stumble, we fracture, we divide, but again and again we find ways to weave fragments into something larger. Civilizations rise not through dominance, but through synthesis, through the fusion of disparate traditions into richer cultures. Individuals grow not by eliminating contradictions, but by integrating them, balancing shadow and light. In this sense, string theory mirrors our own evolution. It is not just a scientific framework. It is a metaphor for existence itself. Countless invisible vibrations woven into a fabric of meaning, imperfect but beautiful. This is the moment when the narrative breathes again. The despair of Part 12 transforms into resilience. The chalkboards, once monuments to futility, now appear as canvases alive with possibility. The abandoned symbols take on new significance. Perhaps they are not the end, but the beginning of something greater, something not yet seen. It is here that philosophy re-enters the picture, not as a consolation prize but as a partner. For what string theory truly offers may not be answers, but new ways of asking questions. It compels us to see reality not as static but as dynamic, not as a machine but as a melody, not as a fixed edifice but as a pattern in constant flux. And in that shift lies hope. Because even if string theory is never proven, never confirmed by experiment, it has already altered the way we think. It has opened doors to ideas that will outlive it, seeding the future with possibilities we cannot yet imagine. The narrator's tone here turns contemplative, weaving together the scientific and the poetic. The world is no longer divided into the certainty of physics and the mystery of philosophy. It is a world where both dance together, each incomplete without the other. The scientist is no longer just a technician of equations, but a philosopher in the truest sense, a lover of wisdom, a seeker of truths too vast to be contained in formulas alone. The B story of humanity's philosophical evolution now merges with the A story of string theory's scientific odyssey. They become one. The search for unity in the cosmos reflects the search for unity in ourselves. The struggle to reconcile relativity and quantum mechanics mirrors the struggle to reconcile reason and wonder, knowledge and humility.
The tension remains, the questions remain. But the despair has lifted, replaced by a renewed sense of purpose. This is not the naive optimism of the early days of string theory, nor the crushing pessimism of its collapse. It is something more tempered, more mature, a recognition that the truth may always be just beyond our reach, and that is precisely what makes the journey worthwhile.
For science without humility is brittle, philosophy without science is hollow. But together, they form a dialogue that is as old as humanity itself, a dialogue that propels us forward even when answers elude us. The moment crystallizes into a single haunting realization. The value of string theory is not only in whether it is real, but in what it reveals about us. That we are beings who will chase even the faintest thread of truth, even into the abyss, because we cannot do otherwise. From this synthesis, the path forward emerges, a path not of certainty, but of courage, not of final answers, but of enduring questions, not of domination, but of partnership, with each other, with philosophy, with the cosmos itself. The break into three is not a resolution. It is a reorientation, a shift from despair to determination, from collapse to integration. It is the recognition that even in failure there is progress, that even in darkness there is light. And as the narrative closes this chapter, one question begins to pulse like a heartbeat. If string theory is not the final truth, then what new revelations might it yet point us toward?
The journey is not over. The threads still hum. The fabric still shimmers. The next act awaits.
The threads converge. The entire journey, through soaring hopes, bitter collapse, and the fragile light of integration, has brought us here, to the edge of the final confrontation. String theory, once the whispered secret of dreamers, now stands as both promise and paradox, daring us to test its resilience against the most unyielding of questions. What in the end is real? The finale is never a single moment, it is a storm. The battleground is vast, stretching across particle accelerators, supercomputers, black hole horizons, and the philosophical chambers of human thought. Here, string theory must prove its worth, not by perfection, but by persistence. By showing that even in its ambiguities, even in its countless branches, it has left us closer to understanding than we were before. The questions surge like lightning across the sky. Can the theory predict observable truths? Can it anchor itself in the solid ground of experiment? Or is it destined to remain a ghost, a mathematical dream woven from dimensions we can never touch? The scientists press forward, refusing surrender. In the vast data of gravitational wave detectors, hints emerge of distortions beyond Einstein's equations. tiny ripples that may be signatures of string-like vibrations. In the spectra of dark energy, whispers of anomalies appear that could align with predictions once dismissed as fanciful. In the ever-expanding field of holography, the idea that the universe itself is a projection from a deeper, string-based reality grows harder to ignore. This is the assault on the fortress, the storming of the castle. Not a single decisive blow, but wave after wave of insight, testing the walls of mystery. And yet, the adversary is formidable. For every piece of suggestive evidence, there are gaps, contradictions, and doubts. The vast landscape of string vacua, 10 to the power of 500 possible universes, remains a labyrinth without a clear path. Critics argue that a theory predicting everything predicts nothing at all. The danger looms that string theory, no matter how beautiful, might prove untestable, forever retreating into the safety of abstraction. But here lies the power of the finale. It is not victory alone that matters, but transformation. The theorists, like heroes weathered by their odyssey, discover that their true triumph is not the conquest of mystery, but their survival within it. For string theory has already changed physics. The holographic principle, born in its equations, has redefined how we think about space and time. The study of Calabi-Yau manifolds has reshaped mathematics itself. Black holes, once impenetrable enigmas, now reveal secrets through the lens of string-based entropy. Even if strings are never seen, their echoes ripple across fields far beyond their origin. And in these echoes, philosophy steps forward once more. The meaning of reality is not found in the certainty of proof, but in the persistence of pursuit. The universe may never yield all its secrets to us, but perhaps its deepest truth is not an answer but an invitation to keep weaving, keep unraveling, keep reaching beyond what we can know. As the finale swells, the human story becomes inseparable from the cosmic one. We are not passive observers of the stringed universe. We are participants. Our minds, our questions, our equations, our awe, all of it becomes part of the cosmic symphony. The strings vibrate not just in hidden dimensions, but in us, in the very act of searching, of imagining, of refusing to accept the limits imposed by the visible. The transformation is complete. String theory is no longer just a hypothesis, nor just a failed dream. It is a mirror, reflecting both the grandeur of the cosmos and the fragility of human ambition. It is a reminder that knowledge is not a straight path, but a labyrinth, where even wrong turns lead us closer to truth. And so the finale leaves us in a place at once triumphant and haunted. The fortress of mystery still stands, but its walls have been marked, its foundations shaken. The quest continues, not as a march towards certainty, but as an embrace of the infinite. In the storm's aftermath, the narrator's voice turns contemplative, almost tender. For what has been won here is not proof of string theory's reality, but proof of our own. Proof that we are creatures who will chase the faintest vibration, who will weave meaning from shadows, who will risk despair for the chance to touch wonder. The music fades, but one question lingers like the final note of a symphony. If the universe truly is woven from strings, then what new revelations await us in the vibrations we have not yet heard? The castle remains, the storm recedes, but the fabric still shimmers alive with possibilities. This is not an ending. It is the moment just before another beginning. Return for a moment to the first vision, the cosmos suspended in silence, a dark ocean without horizon. In that opening image we glimpsed threads, faint, trembling, hidden just beneath the fabric of reality. Now at the end of our odyssey, those threads shimmer with new meaning. They are no longer abstract whispers, nor the idle dreams of physicists scrawling equations in chalk. They have become, in their strange persistence, the haunting refrain of our story, that the universe may not be built of particles, but of vibrations. That reality itself is a song. The final image is not a static one. It is alive, shifting, refusing to be captured. Strings tremble not in isolation, but in great cosmic harmonies, spanning unseen dimensions, weaving galaxies like beads upon a web. They stretch from the smallest quanta of energy to the furthest stars, binding the universe not with force, but with resonance. And if this image feels overwhelming, it is because it must. For what lies before us is not just the culmination of science, but the confrontation with mystery itself. We see again the theorists who dared to dream, Veneziano, whose strange function in 1968 sparked the first fire; Witten, who unified the 5-string theories into a single vision; the countless mathematicians, cosmologists, skeptics, and visionaries who pushed forward through doubt and derision, never knowing if they were chasing truth or illusion. Their faces blur into the tapestry of time, their questions immortalized in the very act of asking. And we see too the failures, the dead ends, the equations that collapsed into nonsense, the predictions that dissolved into silence. We see the skeptics standing firm in their demand for evidence, their insistence that beauty alone cannot make truth. Their voices matter because they remind us that knowledge without rigor becomes myth. But within this interplay of belief and doubt, persistence and collapse, a deeper truth emerges. String theory has already transformed us. Even without proof, it has reshaped mathematics, reframed cosmology, redefined what physics can dare to ask. It has pushed us to think in 10, 11, even 26 dimensions. It has led us to holography, to black hole thermodynamics, to ideas that have permanently altered the landscape of thought. This is the final image, not the certainty of strings vibrating in hidden dimensions, but the certainty of human beings vibrating with curiosity, refusing to accept the visible as the whole. The cosmos itself becomes a metaphor. Each galaxy, each particle, each life threads in a vast pattern, impossible to see in its entirety. We exist as notes in a symphony we can never fully hear, but whose resonance we feel in every breath, every thought, every dream of the stars. And there is within this vision a haunting humility. We may never prove string theory. We may never detect a Calabi-Yau manifold folded in some higher dimension. We may never hear the literal hum of those primordial filaments. But we will have tried. We will have reached again and again into the silence, asking whether there is more. And in that reaching we will have revealed ourselves, restless, relentless, unwilling to accept the simple when the infinite beckons. Imagine standing on the edge of the observable universe. Behind you lies the long path of human history, caves, fire, the wheel, equations on dusty blackboards. Before you stretches the unknown, wrapped in a fabric you cannot touch. Do you turn away, content with what is known? Or do you step forward, knowing the fabric may unravel in your hands? That is the essence of the final image, not strings alone, but the human spirit entwined with them. The strings are metaphors, yes, but perhaps more than metaphors. They are the shadows of truths too subtle for our present tools, the glimmers of realities that demand not only better machines, but deeper imaginations. They invite us to consider that the universe is not made of objects, but of relationships, not of solidity, but of song. They challenge us to abandon the comfort of certainty for the beauty of possibility. And as the journey closes, the narrator's voice deepens, heavy with awe. For in the end, the question lingers not as a wound, but as a gift. Is string theory even real? Perhaps that is not the right question. Perhaps the truer question is, what does it mean that we, fragile beings on a tiny planet, dared to imagine such a thing at all? The camera of the mind pulls back one final time. Galaxies swirl like sparks in a cosmic loom. Invisible strings hum in silence, stitching together a universe that is both infinite and intimate. The fabric trembles, and for a moment it almost feels alive. The image fades to black. But in the silence that follows, one thought reverberates. The unraveling itself may be the answer. At the edge of imagination, the cosmos falls silent. The great tapestry of galaxies and the equations etched into blackboards across decades fade into the background, leaving only a whisper, strings, elusive, mocking, perhaps laughing at us from the folds of dimensions unseen. The journey we have taken across 15 chapters of hope, despair, triumph, and doubt does not conclude here. It transforms. For if string theory is real, then every atom of your body is not a particle at all, but a chord. Every heartbeat is a resonance, every thought a vibration strummed across dimensions your eyes will never see. But if string theory is not real, if it is only an elaborate mirage woven by human longing, then what have we lost? Nothing. For in reaching toward it, we revealed something truer still. That the universe may be unknowable, yet the act of pursuit grants it meaning. This epilogue, then, is not an answer but a reflection, a lingering note in a symphony unfinished. Consider this irony. The greatest claim of string theory is unification. Gravity, electromagnetism, the strong and weak nuclear forces, all stitched into one coherent framework by the tiny oscillations of filaments smaller than any microscope could hope to capture. Yet its greatest flaw is fragmentation. Tens of thousands of possible solutions, landscapes sprawling into infinity, universes upon universes hidden in mathematics, too vast to resolve, unity that gives birth to chaos, order that multiplies disorder. Could there be a more fitting mirror of existence itself? It is this duality that makes string theory more than physics. It is myth. It is poetry. It is a mirror in which humanity confronts its own contradictions. Imagine ancient storytellers gathered around a fire, weaving myths of gods and giants to explain the thunder, the stars, the birth of the world. Imagine mathematicians centuries later, weaving equations instead of tales, yet aiming at the same goal, to explain why there is something rather than nothing. String theory belongs to that lineage. It is both an equation and a myth, both an attempt at truth and an act of imagination, and perhaps that is why, even if it fails, it will never truly die. The physicists of the 21st century wrestle with strings the way their ancestors wrestled with constellations. They map patterns that may never be touched, never be tested. They name Calabi-Yau manifolds with the reverence of priests naming temples. They argue over the swampland conjecture with the fervor of theologians. And in their devotion, they reveal something astonishing. The act of seeking itself is sacred. For string theory does not merely describe the world, it dares to describe all possible worlds. The multiverse, if it exists, would not be a fringe speculation but a direct consequence of these vibrating strands. Imagine it, an infinite choir of universes, each a different arrangement of strings, each a variation on the same cosmic theme. Some where stars never form, some where life never stirs, and some, perhaps, where beings like us gaze upward, asking the same question. Is string theory even real? And yet the irony deepens. For as much as strings offer infinity, they also conceal. To detect them may forever elude us, their scale beyond reach, their signatures buried beneath energies no collider will ever achieve. It is as if the universe dangled its most profound secret just outside our grasp, inviting us to stretch, to strain, to ache with curiosity. In that unfulfilled longing lies the heart of the human story. Even if strings are not real, the longing is. So let us imagine one final time. Not equations, not laboratories, but the strings themselves. Invisible threads, finer than thought, vibrating in rhythms beyond music. Each one a potential particle, each one a note in the score of existence. They vibrate not in the vacuum of space, but in the silence of higher dimensions, curling and folding in on themselves like secrets. Perhaps they are laughing, perhaps they are crying, perhaps they are neither, only humming with the inevitability of what is. Now, a whisper of amusement. What if the universe is mocking us? What if every breakthrough we celebrate, the holographic principle, black hole entropy, dark energy constraints, are but crumbs scattered across the floor, while the true banquet of understanding lies hidden behind a locked door? And what if the strings themselves hold the key, but play a cruel trick, offering only riddles in place of answers? Would that make our search absurd, or would it make it heroic? For is it not in the absurd that humanity proves its greatness? We chase shadows in mathematics. We build machines the size of cities to smash particles like children breaking toys. We argue across centuries over infinites and singularities, all while knowing that the truth may remain forever out of reach. Yet we do it anyway. That, more than any theory, is the ultimate testament to what it means to be human. In this sense, string theory is real, not in the universe, but in us. It is real because we believe in it enough to chase it, because we are willing to devote lives, fortunes, and dreams to the possibility that beneath the chaos lies harmony. It is real because it has become part of our collective imagination, part of the story we tell ourselves about who we are and what we might become. And so, as this tale draws to a close, the final image is not of strings, nor of equations, nor of galaxies. It is of a human face illuminated by starlight, eyes wide with wonder. It is of the quiet intake of breath when one dares to imagine the unimaginable. It is of the silence that follows a great question, heavier than any answer.
Is string theory even real? Perhaps the answer is not to be found in mathematics or in machines, but in that silence. The silence where awe resides. The silence where we recognize the vastness of what we do not know. The silence where the universe speaks, not in certainty, but in song.
And in that silence we may hear it, the faint trembling hum of strings, weaving a story we are only beginning to read. The curtain falls, but the question lingers. Thank you for joining us on this extraordinary journey through the cosmos here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday at 7 p.m. Eastern, where we unravel the darkest mysteries of space.